Alright guys, we have another question from the third chapter of the Meriam textbook, Engineering Mechanics, and we have a 20 kilogram uniform rectangular plate that is supported by an ideal pivot at point O and a spring which must be compressed prior to being slipped into place at point A. So we have this spring in here which is in compression. So the force that the spring is applying to this rectangular plate would be in this direction since the spring by itself is in compression. So we need to we know that the modulus of the spring is 2 kilonewton per meter, and the question is asking what must be its undeformed length L. So we are in equilibrium. We're going to start with the free body diagram as always, and we're going to draw the free body diagram for the rectangular plate. And let's see what forces we have in here. So we're going to have the weight of this plate, which would be exactly at the center since we have a uniform rectangle plate. So that would be our weight, which is going to be mass times acceleration of gravity. We know our G is 9.81 meter per square second. If you just multiply that by mass in kilogram, we're going to get Newton force. So we have the force of this spring, and we can consider two reactions at point O, OX, and OY. But the question is I'm not asking for these two. We just call our X and Y in here too. And it seems that if we just do the moment about point O counterclockwise positive equals 0, since we are in equilibrium, we should be able to find the force in the spring, and we know force in the spring is equal to the modulus times the displacement. So we should be able to find the displacement, which would be the difference between the undeformed length L and the length that we have now, or basically this difference that we have in here is going to be our displacement. So for finding the L, we just have to add 1.1 meter plus our displacement, and this is what the question is asking. So let's just find the displacement in the spring. So let's see what we have. So we're going to have the moment of the weight about point O, which is going to be in this direction. So it will be a negative moment since it's clockwise. So minus 20 times 9.81. And the distance that we have would be the vertical distance to the line of action. So we need this distance. And since center of mass for this uniform plate is exactly at the center, we know the length of this plate would be 0.48 plus 0.12, which is going to be 0.60. So this is going to be 0.3. And we're going to have the same story on the left side, 0.3 from this side too. And we just have to subtract 0.3 by 0.12, which is going to be 0.18. So this distance, we know it's also 0.12. So that would be the moment of the weight. We're going to have the moment of the force in the spring, which is counterclockwise, so plus Fs, and the distance between A and the center and O would be, so now we are looking for this distance. Again, the vertical distance to the line of action, this distance, or what we have in the bottom. So we know we have 48 for this distance. If we just subtract 0.48 by this distance, which we know is 0.15, that's going to give us the distance, which is basically 0.48 minus 0.15. So this is going to give us 0.33. So let's just calculate this. 20 times 9.81 times 0.18 divided by 0.33. And this is going to give us the Fs, which is going to be 107.02 newtons. And now that we have Fs, we're going to use our formula for the spring, K times the displacement. So we're going to have 107.02 is equal to our K is 2 kilonewton per meter. So basically 2000 Newton per meter, because we have Newton on the left side. times the displacement. So our displacement would be, so we're going to get it in meter because that way we can cancel out this meter with this one. So we're going to have that number that we found. So 107.02 divided by 2000, which is going to give us 0.05035 meter. And if we just multiply this by 1000, we're going to get 53.5, and we're going to get it in millimeter. And our displacement would be, as I said, the length L that we are looking for is 1.1 meter, which is going to be 100 millimeter plus 53.5, or we're going to get 153.5 millimeter as the undeformed length of the spring. And yeah, that's pretty much everything for this question. Hope everything was clear. Let me know if you guys have any questions, and you guys take care. I'll see you in the next video. Have a good one.